The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Welcome back to another great episode of our Best Practices webinar series with 7Signal. If you could, please let us know where you're logging in from today. I see a handful of you who have actually joined us early, so thank you for that. We were all just talking beforehand where we are today. So I am in Cincinnati. I'm in Cleveland. Jim Vada is in Cincinnati. I just got back from Cincinnati. And Chris, where are you joining us from today?
Corpus Christi, Texas.
And you said it's 80 degrees?
It's 80 degrees. It's terrible winter weather we're having. So,
wow. Meanwhile, we have some snow up here in Cleveland coming soon, and Jim, how's the weather in Cincinnati? I just left, so I'm curious to see how it is now.
Yeah, it's dreary and gray, and we've got some 40-degree rain on the way.
ooh.
Lovely.
I'd rather be in Texas.
Welcome to winter. All right, I see a lot of you dropping in here. I see Lewis joining us from New Jersey. Thank you for joining us today. I see Keith joining us from Tennessee. Thank you, Keith. I see Chris joining us from Pittsburgh, working from home today. Thank you guys so much. If you can, please continue to let us know where you're logging in from, and we will circle back with you later. So we are 7Signal, the leader in wireless experience monitoring, and we will go a little bit more into depth as to who we are as 7Signal before we jump into today's presentation. So we have a great topic here today, understanding QoS and multi-service wireless LANs. And as I mentioned before, we are joined today by two of our guests, Jim Vada and Chris Minton. Thank you guys both for being here today. All righty, and again, my name is Kelsey. Thank you, Chris. My name is Kelsey Rizzuto. I'm the marketing specialist here at 7Signal. Really excited to dive into this topic and see what it has to hold. And I think, Chris, we did this topic a couple of months ago. Is that correct?
That's correct. Mm-hmm.
Awesome. All right, back by popular demand. We'll see what else we can dive into today. Okay, a couple of announcements before we begin. For those of you who have recently joined us, these will all sound familiar, so just bear with me here. But we do partner with CWNP for every single one of our webinars. So by watching these Wednesday webinars, you are eligible for CE credits. So if you're pursuing some kind of certification, just drop us a message here in the chat or shoot us an email, and we can easily send you over a PDF certificate. Moving forward, we also have a newsletter that we put out every other Wednesday, our troubleshooter newsletter from 7Signal. So if you're interested in receiving that biweekly content, we'll go ahead and drop a link in the chat here as well, so you can go ahead and register. Additionally, we do host a product tour every single Friday at go.7signal.com/tour at 12 noon Eastern. So I'll go ahead and drop that registration link in here as well, because we don't go too into depth with any kind of demo or product here on these weekly webinars. This is mainly just for diving into some different topics and connecting with our Wi-Fi community. But if you haven't recently joined us for a product tour, a lot of exciting updates with Mobileye and Sapphire Eye, so we will go ahead and drop that link in here if you're interested. An exciting announcement here. We do have our virtual user group coming up on February 17th. So we will be going ahead and starting to promote this next week. Expect a little bit more information on this, but really excited to host this and hopefully have a lot of you attend and join us. Moving forward here, we also post all of our slides from each presentation to our Twitter account. So follow us at 7Signal, and those slides will be available later this afternoon. But if you're not on Twitter, that's no problem. All of you should be receiving a follow-up email with access to today's slides. And if you also want to shoot us a message for those and need them earlier than tomorrow, just let us know and we can send it over. Additionally, we post all of our archived webinars to our YouTube channel at 7Signal. And today's presentation will also be posted later this afternoon. So if you want to access that recording, go ahead and look us up there. And additionally, a great reason to subscribe to our YouTube channel is because we're starting to do some merch giveaways for YouTube subscribers. We've recently done it with people who followed our socials, so continue to follow us, but moving forward, we'll start picking some winners for those who subscribe to 7 Signal on YouTube. So stay tuned for more information on that. Another sneak peek here for those of you who have recently joined us. We've been giving a sneak peek every single week of some ROI data from a recent IDC research white paper that we've been featured in. And for those of you who are joining us today, because we appreciate you joining us on a week where a lot of people are out of the office, we're going to go ahead and drop the link to access this report right away, so you'll have more information here. So just stay tuned for that later in the webinar. Another announcement here, this will sound familiar as well. We've recently been featured in the Gartner 2020 Market Guide for Digital Experience Monitoring. 7 Signal has been recognized as a representative vendor for Mobileye. So we'll go ahead and also drop that link in the chat so you can access that report as well. So a lot of links here, so keep your eye out on that chat for all of those resources that you can access. All right, moving forward. So a little history on 7 Signal. We were established in 2007 in Helsinki, Finland, and we're now located and headquartered in Cleveland, Ohio. We are really proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We have over 200 customers, over 30 partners, and 14 patents, which goes to show that the technology you see from us at 7 Signal, you're only going to see from us at 7 Signal. Additionally, we're certified in over 40 countries and are GDPR compliant, which goes to show that we take data and privacy very, very seriously for all of our users across the globe. All right, as I mentioned before, we're 7 Signal, the leader in wireless experience monitoring. And the reason why we're here is because the digital experience matters. And usually when you have a negative digital experience, it typically bubbles up to one of these top 7 Wi-Fi problems that we have here on the left, such as congestion, coverage loss, roaming issues, adapter and driver issues, and more. So what we're able to do to help that is we provide full visibility into the end user experience through an outside-in approach, living on the edge of the network, through our complete suite of Mobileye and SapphireEye. We're also completely AP and device agnostic, so those great tools and technologies that you already have installed, we are incredibly complementary with that as well. So how we're able to detect those top 7 problems, as I previously mentioned, is by running active and passive tests on the edge of the network, looking for things like throughput, latency and jitter, adapter and driver issues, packet loss, giving you a full scope as to what is occurring in your environment and what's the issue behind it. Just to give you a little bit more insight here, so what makes us so different? If you look at your typical enterprise LAN infrastructure, you have those great tools and technologies I already mentioned already installed that are giving you useful data, such as your Riverbed, Cisco, Aruba, and more. But what we can do is pick up where they leave off, giving you full visibility into the user experience through Mobileye. And Mobileye can ultimately be installed on any mobile device, such as your mobile phones, your laptops, your Zebra scanners, if you're in a hospital, workstation on wheels, and more. And ultimately, Mobileye can be installed on any Mac OS, Linux, Android, or Windows device. So when you couple that with SapphireEye, SapphireEye is our software-enabled hardware sensors for service level quality and RF visibility. So through those combination, you're really getting a full perspective as to what's occurring in your wireless network environment. Taking it one step further, that LAN infrastructure that you had in the office might not be as useful now with a lot of us working from home and continuing to working from home moving forward. So you need visibility into your home networks, into your external home networks, such as if you're working in a multi-tenant apartment, if you're working in a house with other users who are also on the network. We're able to give you that perspective as to what's occurring there as well. And as I've mentioned before, work from home is here to stay, and especially moving into the new year, this is going to continue to be a reality. So as I've mentioned before, 76% of remote workers use video conferencing as a part of their daily work, and 68% of those remote workers also have other people working in the same household. So having a nice Wi-Fi connection at home is not just convenient, it's mission critical. You still need to stay connected, you still need to stay productive wherever you're logging in from. And so that's what we're able to help and assist with. All right, thank you for letting me give you a little background on 7 Signal. We're going to go ahead and move forward into our trivia questions for today that Chris provided us. So I'm going to go ahead and launch our first one now. Chris and Jim, can you see this question?
Yes.
All right, awesome. Let's see how everyone does here. So
Not an easy
ACK,
one.
no, Chris is already trying to trick everyone with the first question here. ACK and CTS frames follow which IFS? So I see a lot of you dropping your responses in here now. I'll give you a couple more seconds here. See who can get this correct. Okay, I'm closing this now. All right,
Oh.
Chris.
Fun, Chris.
How did we do?
Yeah, that's good. 35% got it right.
Awesome. Well, thank you so much to everyone who dropped their answers in here. And I think, Chris, we have a second question for today. So we'll go ahead and see if that one's a little bit easier.
Yeah, I did 3, so I thought maybe I'd get a good easy one there too, but yeah, maybe the second one's a little bit easier.
Let's see. All right. Can you guys see this question now? All righty then.
I don't think this is any easier, Chris. I think we can tell you've been studying for some CWNP certifications lately.
I couldn't help it.
Excellent.
I see a lot of you starting to drop in your answers a lot slower than the last one, but slowly but surely here.
Little hint that HCF is hybrid coordination function. Is that right, Chris?
That's right.
Yeah.
Alrighty then, I will go ahead and close this poll now. Thanks for answering. All right, guys, how do we do?
Good opportunity. So yes, good job, guys.
Awesome.
The question just looked hard.
Too intimidating.
That's right.
All right.
Yeah, if it was fill in the blank, it would be much more difficult.
That's right.
Alrighty then, thank you guys. I'm going to go ahead and close this poll now. And we're going to go ahead and pass the controls over to our special guest today, Chris Minton. All right.
Awesome.
Chris, you should get controls now.
Okay. Alrighty. So I'm going to share my screen. Hopefully you guys can see just a regular background and the PowerPoint presentation. Is that correct?
Yes.
Yep, looking good.
All right, great. So I believe this is the last webinar, best practices for 2020. Is that right, Kelsey?
That is correct.
So, and we've done one a week. So what is that, 52 weeks in a year?
Yeah.
My goodness.
We got
so
the final one.
You guys could be the final ones. Woohoo. Looking forward to saying goodbye to 2020 and looking forward to a great 2021 like everybody. I know it's holiday season for everybody. Thank you guys so much for attending. You guys could be anywhere at this time, and you chose to be with us. And so that's highly appreciated. And I think you guys are going to find this exciting. Just like you guys, I am working from home. I've been working from home for quite a while. And I have all my kids and everybody's off for the holidays and trying to figure out how to get them to be quiet while I was doing this. And I was like, well, I'm going to be on a meeting. The webinar wasn't resonating. And I was like, you know what? I'm going to be making a YouTube video with a whole bunch of really cool people. And all the kids were like, okay, we got it. We're going to be quiet. We got you, Dad. So, the idea of, having this on YouTube was what got my kids to be quiet for these few times, hopefully. But this is our topic, understanding quality of service and multi-service wireless LANs. This is me, just like you guys. I've been in the business for quite a while. That's coming up on 23 years now. had the honor of working at some really great companies over the years, and just super excited to be working with 7Signal. And you can see over the years, I've gotten wider and less hair, but I'm still always constantly amazed to be in the IT business and all of the different things that we're doing. It's just it's really cool. It's a great career, and it's a great path. But talking about yourself is always boring. So let's get to the real meat. So this is what we're going to be covering today: understanding QoS, and here are our topics. Again, just the base of what we talked about, a little bit of a hint right there. And right off, I want to start with the definition by CWNP, right? So I'm going to read this to you guys. Please permit me. The traffic so QoS is traffic prioritization and other techniques used to improve the end user experience. For you wired guys in your wireless, obviously, when you see 802.11, that's always something with wireless. When you see 802.3, that's wired. So the IoT 802.11e includes QoS protocols for wireless networks based on access categories, right? So that's pretty simple of the definition. So, any questions? Right? QoS is a really interesting topic, and I was trying to think about the best way to talk about QoS and how it's really resonates in the wireless world. And I thought, well, no better time than just to show the present, right? So I am talking to you guys on this screen and on this computer. Kelsey and Jim, can you just make sure that you guys can see my screen?
Yep. Looks
Okay.
like a PowerShell Windows
Yeah,
up.
absolutely. So just to show you guys what's happening, this is my wireless NIC on the machine that I'm talking to you guys, that you guys are viewing and you guys are hearing right now. Good news that I'm connected. If not, there'd be a problem. My SSID is Mitten, very original. It's my last name. And what I wanted to show you guys is, here's the BSSID I'm connecting to. We're going to reference this, and the authentication and the channel, yay! But look at this receive rate and transmit rate. So this is little b, right? So these are megabits, right? So I'm receiving and transmitting on the wireless at, a really great speed right now. And my signal strength is, 92%, and it looks fantastic. And so, as you're curious if it stays like that, yeah, looks like it's staying, pretty steady. So 866 for receive, that's pretty decent. So we'll hop here into my nice little converter. That's a pretty good download speed. I can download 108 megs per second at that data rate on the Wi-Fi. So that's really interesting, and that's really important. But I'm curious what it looks like to the cause and solution to all of life's problems, which is the speed test. I don't know how many of you guys have used speed test or had customers say, hey, my network's doing fine or doing terrible about speed test, right? But away I go, right? So as I'm doing that, right, I'm looking pretty decent. Data rate's looking good. Nice. The fastest internet ever. Get an upload speed. Connecting really well. Let that drop. Nice. Well, wait a minute, right? My signal just dropped, and my receive and my transmit rate just dropped. So that's interesting, and this relates into QoS. So let's have a look. So lucky for me, I have a Mobileye, and I have it actually installed on the machine that we're talking, and I'm hot now. You guys can see this right here. And just to make sure that we're looking at the same thing, there is my MAC address, right? Let's just make sure, keeping honest. Yep, there's my MAC address, and that is me. So I'm looking at the last day, last 24 hours, and let's have a look at my data rate journey as I move left to right. All over the place. Interesting, right? So must be my signal's been changing. The signal over the last 24 hours is staying right about the same. You can see it change to the right, What's a good signal strength, right? So we're looking at us at 7 signal. We say -70 is a pretty decent signal rate, and -30 is almost too strong. So I'm actually have a great signal. So why the change in data rates? Have I moved connection type over the last 24 hours? Nope, still on AC. That's still the network I'm on. And this BSSID, if I changed, if I hopped 2545, let's keep us honest. Yep, that's me. Okay, so this is interesting. So I am working from home. I'm talking to you guys on a laptop. The laptop physically hasn't moved. Oh, my goodness, Jim, it's been with 2020. I don't think that laptop's moved in 3 months physically. I haven't done any changes. I haven't roamed. I haven't roamed to another 2.4 or changed the bands, which is a complete physical roaming. And I'm sitting here, doing absolutely the same thing, and my data rate's all over the place. So lucky for me, I have a Wi-Fi sensor in the network as well. And I want to look at the same time, a day period. I'm looking at averages of minutes, and I want to see why my data rates are fluctuating. So I'm noticing over the last 24 hours, and just to keep myself honest, there's my NIC, and here's the SSID. All right, 2545, let's just confirm. Yep, that I've been on for the last 24 hours, and notice that at different percentages of the time, I've had completely different data rates. Okay, so I'm the only one on this network. I have completely different data rates. And why? So if I look over here, I look at some part of the time I was at this data rate and so forth. But notice the MCS value is different. And we'll talk about the differences between these two here in a second. So if you guys can read this, it might be a little small on the screen, but I'm running at this rate. This is my network's type. I've been put in this queue of MCS5. I've got an 80 megahertz wide channel. I'm using a normal guard interval, and this says I have 2 spatial streams. What that SS is? Can I confirm that? Yep, there's me. Okay. So how did I get to these numbers? Well, this is when we come to our great little MCS, our modulation encoding schemes, right? So I'm using 2 spatial streams during that time. And I believe I first started at, or some period of time, I was at 5. All right, so here I am. And I was using 80 megahertz wide channel. So look at that, 468, right? Okay, so that makes sense. 52.6, MC6, right? Look at that. It's all making sense. And then lastly, or 585, let's not forget him. On 7, there we are. And then what about this last guy when I've got my really awesome speed, my 650 data rate? Notice the short guard interval on MCS 7, right? So there I am. So awesome. So now I know that I have been put in different data rates, and that's why my data rate has been fluctuating over the last 24 hours. But why? Why am I not running at a certain rate 24/7? I mean, this is a work from home environment. To troubleshoot, I'm a dream client here. I'm not roaming. I'm not hopping around. I don't have anything going on. So why different data rates? Just the device sitting on the same 24-hour period. So is it the signal strength that makes my data rates change? Or is it something else? Right? So what's the main factor for your MCS values to change, right? You guys can throw that in the chat window if you like, right? Signal to noise ratio. So usually in the last 24 hours, just to hear or to be able to connect and with a good SNR, I believe it's is it 10 to 15 dB? Is that correct, Jim? You can keep me honest, just to be able to hear. And then I believe a poor connection or poor SNR value is 16 to 24, right?
Yeah, I'd say 20 dB or more of SNR is usually going to be pretty good, and your MCS is going to start to drop into those lower values below that.
Yeah, yeah. So I've got during points of time of the day, I'm getting noisy, right? And I'm dropping into different data rates. And for a Wi-Fi network, it's fast, 650, some of those MC rates are really quickly. But I don't know if you guys can see this, but this is, when we're talking about push to talk voice over IP Wi-Fi type devices, right, that are just connecting in Wi-Fi, this is a big deal with those data rate changes. And this is just one device. Let's look at it when we're looking at a whole bunch of different devices over a period of time with all different data rates, right? So this poor fella, running at a 12 data rate, right? The download speeds are just really poor for this guy. And you're having to deal with all of these different devices running. And for my wired engineer friends, we're so used to when you plug into a switch port and you plug a terminal or a PC or a laptop into the switch port, you're used to getting that guaranteed rate of traffic. You'd be really surprised in the Wi-Fi network, and for you Wi-Fi experts, a lot of you guys are here on the call, you guys know that the data rates and the different types of network types, FIS, right, really make a big difference in your network. And so what I'm trying to demonstrate to you guys is that QoS, especially on a wireless network, especially when we're talking just two devices communicating just from the Wi-Fi, having that quality of service in there is a really, really important factor. So let's hop back to the presentation. Jim, was there anything you wanted to comment on that?
No, I think you covered it well. Thanks.
Okay. This is, I like this. It's at some points, you feel like QoS on a wireless network kind of feels like this. Sometimes, it's really kind of how you look at it, right? So let's talk about the issue, right? Because this is what we're trying to get to, as you guys know. This is what we need to guarantee before things start getting dropped in a Wi-Fi network or start having issues. So we need to start back with the beginning. And I want to make sure I'm cognizant of my time here. I don't want to go too far over. But back in the day, right, and for you guys that are wired, again, 802.3 is wired, 802.11 is wireless. They do collision detection, or CSMDA, and collision avoidance completely different, and it's a paradigm shift. And we talked about this, Kelsey, on our first call. It's sometimes hard that when you have to support both to think of them different. It's like routing, intra VLAN versus intra VLAN routing, completely different types of the way the routing protocols and the mechanisms work. But with wired, we have the luxury of detecting collisions, right? Wireless, you can't. And we're in the business of avoidance. And since you can't collect anything or detect anything, it's really interesting for how wireless does this. And so I have a nice little demonstration for my second favorite demonstration. Here is a video of a collision. That feels like my 2020. I don't know how you all feel about it as well. But let's
Mine too.
I remember that video from last time. I still laugh about it.
I love it. I love it. I probably shouldn't like it as much as I do, but I do. So let's talk about in the past here, when 802.11 first came on. It was really focused in on really just getting carrier sensing and just making sure that the devices had the ability to really just communicate. And not step all over each other. I don't want to say there wasn't any thought, because these are a lot of guys, engineers, a lot smarter and brilliant, more dedicated than I am. But at the time, there was not priorities put in for data. It was just really just making sure that devices didn't just jump all over each other, right? Avoiding those collisions. And they came up with this great little space that from the Wi-Fi side of the house, we know very well. Now, to move into QoS with the 802.11e, they added an amendment, right? And the amendment addressed QoS, and that's called, again, wireless 802.11e, wireless part being here. And this is the the changes. This was back in 05, which seems like yesterday, but also seems like it was 15 or almost 16 years ago. It's hard to believe. But we've added the enhanced distributed channel access, and we've worked on solving or giving the medium the ability to prioritize traffic. And we use that with some Wi-Fi Alliance certified type devices with the WMM. And it is really a neat concept of how this works. So what they've done in this 802.11e is that they've added a couple of things, right? They added the ECA, but they've added the IFS, and what that comes with a contention window. And this is in microseconds, and this is going to be really interesting, and with priority queues that relate to the WBM. So I won't read this out to you completely, but I just would rather just show it to you guys. So how this works, and I think at 7 Signal, when we say cool, we're supposed to replace it with value. So I think this has a lot of value, and it's very, very cool. But you'll notice here, again, with the AFIS, and you'll notice this demonstration of a little bit of a longer or shorter. This is time, right? So a shorter AFS period means the message has a probability of being transmitted with low latency, right? Because it's going to be sent faster than something that's queued with another priority. And for the interest of the priorities, and again, we're just talking on the Wi-Fi spectrum here, this is what our contention window looks like. So we have our IFS with our AFS space, and the ACs are the access category, and this is the contention window. So in the WBM, this is just background. So anything that's classified as background gets a contention window from 0 to 15 microseconds. I might have said milliseconds a second ago. This is microseconds. And I forgot to use my pointer. I even had a note that said, use your pointer.
Yeah, that's all right, Chris. I think it's really interesting that there are these two techniques used to establish the QoS. One is a predefined interframe space for each access category. That's, in a way, it's deterministic. Then there's the contention window, which is probabilistic. It's interesting that both of those techniques were employed. Of course, we have to have the contention window because all this is uncoordinated. So we can't have just everyone use the same interframe space and have nothing else, because then there'll just be collision after collision. But it's interesting that both techniques are used.
Yeah, it's just brilliant. And the more that I read and research on this, Jim, the more I'm just like, well, this is really a really nice piece of code, and a nice response, right, to the solution of how do you add prioritization into a standard that's already been released, right? And again, here we see our queues, right, in microseconds. And so voice, has the ability to have a 3 to 7 microsecond opportunity to send, and then they get a little bit bigger. And how these relate to each other, as Jim had mentioned, was with the WBM, right? So you can easily hit these and see how these guys get categorized. So WMM enabled devices are going to be having these buckets, right? And they work together. Let me just change this next screen. So I think it's really interesting that you can see this in action, and we see it in the beacon frame. So this is my AP doing a broadcast, and it's letting me know here that it's got WMM enabled, and it also shows me in the parameters. And you guys can see this too if you can do a capture of it. Right? So you can see that here's your contention window with the microsecond setting set for best effort. We've got one for background, which match the settings, and then for video. And again, these are microseconds, right? And then voice, right? So again, I'm using my prop here, and just think about all of the, especially in healthcare, and live services where you have a lot of people walking around really quickly and talking and using these push-to-talk Wi-Fi enabled devices or scanners that are really quickly, they need to have a fighting chance, especially when we looked at the data rates earlier about different devices, right? They need to have a fighting chance of getting on that network and sending their information through. So in a nutshell, that is how the QoS in wireless actually works. That was the concept. And as Jim had mentioned, you probably heard him say probabilistic. That is the way that, Wi-Fi QoS, one of the main things is probabilistic priority mechanism, right? That you got a shot. You got a shot that you're going to have your prioritized traffic get there quickly. Now, most people, and all of us too, when we talk about QoS, we're really thinking end to end. Like, so at the beginning, when I showed the data rates of my device, there could have been a conversation about, do I have QoS enabled from my device all the way to the GoToMeeting that you guys are seeing, right? SD-WAN has a lot to do with that. I know you wired engineers, that's really gone really as a good solution for that. And as you guys know, trying to do QoS from hop to hop is really where it gets difficult, and it gets even more confusing so as you dig in just the Wi-Fi. So I threw a few things down here that kind of are some of the biggest problems we see when we're trying to do a end-to-end QoS solution. Depending on how you have your wireless environment set up. If you're completely cloud, if you're controller based, if you're a hybrid, it's a little bit different on who actually is doing the tagging. The main issue is this right here, is that usually when there's lots of issues about QoS when it comes to wireless, as soon as that wireless tag leaves the wireless network per se, it sometimes come back completely different, tagged in a different category. There's a classification system that they're working on with that. A lot of the different vendors do things very different. It definitely takes into some look into. But this is the good thing, and this would be maybe the one thing I would hope for you guys to walk away with this in our last webinar for 2020 is that that is the main thing when it moves from wireless to wired and then wired back. Sometimes it gets tagged different, and you can see, and I've left some resources for you guys here, how the different taggings match up to the other different tagging mechanisms. And I wanted to talk about use cases. So when we talk about quality of service, I'm really focused on the Wi-Fi piece of it, especially when it comes to my little prop here. I think these use cases here are it has to be turned on, and I hope that the data rate example, especially in wireless networks, especially devices using older technologies that are running at different data rates, QoS is extremely important to have that enabled for devices like this. Right. And I wanted to leave you guys with a reference to everything that is in this PowerPoint presentation. I do want to note this one right here. It's not referenced in the PowerPoint, but this is a great podcast to listen to about just QoS. I found it immensely helpful. Every once in a while, I'll listen to it just for fun. And then we have listed all of the information and references here for you if you guys would like to look into more conversations or move into deeper. You've got the reference and everything that was cited was here as well. And with that, I think it's time to move to Q&A.
All right, thanks, Chris. Nice work. And I want to invite anybody who's been listening in to drop questions in the questions and answers panel. We'll get those to Chris, and I'll take a shot at some of them too. Good question here from Charles, Chris, who says, what process in Windows 10 sets the traffic flag? Is it different for UDP or TCP?
What process in Windows 10 sets the flag, UDP or TCP? That's a great question. Jim, do you know the answer to that one?
Yeah, this is where things get pretty murky because on the infrastructure side with the access points, we can really control the WMM tags, which that's what we're going to talk about specifically.
To. Gotcha.
Right, because we have layer 3 and layer 2 QoS mechanisms. Wi-Fi just uses that WMM mechanism in layer 2. And those, on the AP, we can control that by looking at traffic, identifying it by perhaps the source IP and port, or maybe using application visibility to identify traffic and then applying tags to it, or just by trusting the tags, that are coming from the IP packet, looking at the DSCP header and converting that into a WMM tag that fits the same class of service that you need. From the clients, it's a mixed bag. So like an enterprise voice over Wi-Fi handset that's a dedicated voice handset probably is tagging its voice traffic with the right WMM queue as it transmits.
Mm-hmm.
On, sort of general purpose computers like Windows and Macs, it's really a mixed bag as to what tags they're using. And usually it's left up to the application that's generating the traffic to apply the right tagging. And, it's hard to know what they're really doing unless you do a packet capture of that traffic. So
that's right.
Set up an open SSID with no encryption, for testing and run run that Skype for Business or whatever application you're interested in, and run a packet capture and look at the tagging. And if it's an open SSID, you can see the WMM tagging and you can see the IP DSCP tagging inside that packet capture, which is helpful there too. I will also mention though, in Windows, there are GPO controls you can use to apply QoS to all the traffic coming from certain applications. So look into that as well. But yeah, in general, from clients, it's really a mixed bag.
Mm-hmm.
Chris got a question here from Thomas, who says, how does the WLAN controller determine the type of traffic in order to apply the correct tag?
Great question, right? Depending on the controller and the vendor, right? It's a mixed bag, wouldn't you say, Jim? I mean, it's the controller has to trust what the application is telling it to be, right? In my security days, we used to mess with that, where you could change the priority. It's gotten a little bit harder to do with deep packet inspection now. That's usually running on a lot of these devices. But you can choose, or I believe it has, and Jim, correct me if I'm wrong, but the controller has some logic in it that has classifications built into the tables.
Yeah, that's right. In the sort of ideal world, you've got end-to-end QoS on the Ethernet network, and the controller's picking up those frames to transmit wirelessly, and it just converts the tagging on those frames into the appropriate WMM buckets. A lot of the time, though, that's not, end-to-end QoS isn't implemented. And so you can use application visibility on the controller to try and identify traffic flows from certain apps, and then apply the right QoS at the controller.
Yeah, it's just like you said earlier. You definitely don't want to. You want to believe what the controller says it's going to do, but you definitely want to do a packet capture and have a look for yourself, right?
Yeah, for sure. Maybe time for one more question here, and then we'll wrap up. Nick says, if WMM doesn't turn on in the wireless LAN, does it mean that there isn't any QoS in this wireless LAN?
So that's half correct, right? Yeah.
Yeah, if
Mhm.
if WMM is not enabled,
Mhm.
there's two consequences. There's no QoS, and the highest, well, the data rates that 802.11n and 802.11ac introduced are disabled. You can't use those faster data rates.
Mhm.
WMM is required for those to be in use. So, there used years ago, there were a lot of clients that struggled with WMM, and so one of the ways that that was fixed was by disabling WMM globally on an SSID, because there's just certain clients, that didn't get along with it, and that helped. But the consequences of that are pretty severe, and today
Yeah.
it's pretty rare to find clients that can't handle that, and they, you probably shouldn't let those bad apple clients ruin the experience for everybody else. So turn it on.
Yes, and I've seen just recently in some controllers that option's still available, which
Yep.
is really a little bit disconcerting.
Yeah, unfortunately, there's still those bad apple clients out there that need special consideration sometimes. All right, Kelsey, I think that about wraps it up.
All right, awesome. Thank you, Jim, and thank you, Chris. And thank you to all of you who took the time out to join us today. As we said, we know this is a really busy time of year for everyone. So we really appreciate you spending time with us today to dive into this topic and join us for the last webinar of 2020. So thanks, everyone, and we hope to see you next week for the first webinar of 2021. Have a great day, everyone.
Thank you, everybody. Happy
Thanks,
New Year's.
Chris.
Yep, thanks, everyone.
Thanks, Jim. Bye, everyone.